Hello, and thanks for tuning into this session on splicing the identity-based access gene into your infrastructure DNA with HashiCorp Boundary. I'm Joe Thompson, a staff solutions engineer at HashiCorp in our Field Enablement Innovation Lab, which is one way of saying my job is to help make sure our technical field folks can do their jobs, showing off how awesome our products are. I might be biased just a little. I've been here about 2 years so far, but I've been in IT for about 27 years, in fields from consumer internet access to online gaming, digital print production, and finally, infrastructure services. For about the last 15 years, I've worked with what we now call cloud-native technologies, from some of the earliest forms of virtualization, API-driven infrastructure, and high-availability distributed applications, right up to modern platforms. In short, I've deployed a lot of infrastructure in a lot of different ways and seen a lot of patterns in how that gets done. But no matter what the pattern of the deployment, almost every environment needs some form of secure traffic ingress. And this often ends up being an extra layer on top, built after the fact. It's a bit like building a house with no doors, then deciding where they'll be after the house is done, and chainsawing them out of the walls at the very end. And it's especially complex because different people need different levels of access to different spaces and services in your environment. As the environment changes and people come and go, maintaining access is yet more after-the-fact effort, and it never seems to be quite up to date no matter how diligently you manage the ticket queue. There's always a new engineer who got missed, or a new system that isn't in the catalog yet. And we all know when you find these things out. It's never 10 a.m. on a Tuesday when everything's quiet and you can calmly fix things. It's going to be a Sev1 incident late on Friday night when the only engineer available is exactly the one you haven't given access to yet, and the service they need to fix is the one you haven't created the DMZ tunnel or VPN route for. We used to have these kinds of issues with building infrastructure, and the answer was automation and standardization. Secure access for humans has traditionally lagged behind in the ability to leverage these practices. But what if building the new infrastructure created the new connection paths to it automatically? And what if access to those new paths was granted or revoked seamlessly, just by adding or deleting users, not to your access solution, but just your identity provider? What if, in short, your access management solution was built into your infrastructure pipelines, and therefore your provisioning workflows as well? We don't have to saw the windows and doors out afterward anymore. Our house is smart enough to open them up all by itself, and it only opens the doors for the people we want to let in, and only to the rooms we want to let them into. To shift back to the metaphor I used for the title of this talk, it's almost like adding a new gene to your environment, one for self-managing access. Let's talk about Boundary. The basic idea of Boundary is this: human-oriented, identity-based access to your infrastructure. We've had Consul for machine identity-based access to services for several years, and we've had Vault for machine identity-based access to secrets even longer. But although Vault, Consul, and a little glue code to stick them together could provide a workable solution for human use, we wanted to provide something that was better than just workable, something designed for that purpose from the ground up, that could provide that securely and leverage existing identity for it, just as Vault does for providing secrets. In fact, the ideas that became Boundary originally started as discussions around extending Vault, but it quickly became obvious that what was needed was a completely new service. So Boundary was born and made its debut at our first virtual HashiConf in 2020. Almost immediately, interest was high, even with the relatively basic set of capabilities that were available initially. And Boundary has grown by leaps and bounds since. It's even beginning to be used in production by some global-scale companies, despite still being a 0-point version. The Boundary engineering team is rapidly delivering the remaining chunks of the 1.0 vision that were planned from day one. And Boundary 0.7 now has a core set of features around dynamic, identity, and resource discovery that allow the kind of automatic but still secure access that I promised you a minute ago. Now let's look at how it works. The basic components of Boundary itself are simple. There are one or more controllers that handle authentication, authorization, and other management, and one or more workers which create TCP proxies to target resources. These can be standalone binaries running on VMs or bare metal, or they can be running in containers. You can even, and there are some pretty neat use cases for doing so, do things like run a Boundary worker inside a Kubernetes cluster as a pod. Workers can be tagged so that they can be filtered based on those tags later. This is useful if some workers live in special parts of the environment that other workers can't access. Controllers and workers are accessed by clients, which authenticate to controllers over a TLS secured connection. Workers talk to clients and controllers over mutually authenticated TLS. Around Boundary, there is supporting infrastructure. You need at least the following. A database. Boundary needs a supported database. Currently, Postgres is supported for the controllers to store resource and current state information in. This allows the controllers themselves to be stateless. A supported key management service. Boundary uses keys in this KMS for several purposes. Generating multiple levels of keys for encrypting the data stored in the database. Authenticating workers and controllers to each other. Optionally, to provide an initial or ultimate fallback authentication credential. Clients that can use this KMS key can administer Boundary. And also optionally, but highly recommended, for encrypting sensitive data in Boundary configuration files, so they can be stored securely in systems like a VCS repository. Internally, Boundary understands a few basic concepts. Resources are organized into one or more primary scopes, called organizations. Organization scopes are children of the global scope. The global and organization scopes can host one or more authentication method instances, either OIDC or built-in username and password, as well as users and groups linked to the accounts tied to them, known as principals. That's with an AL, not an LE. Roles link to those principals and assign grants of permissions to scopes or specific resources in those scopes to the roles, to control what users can see and access, or to grant administrative permissions to subsets of users. Organizations contain one or more child scopes of themselves called projects. Projects contain roles as well, along with resources specific to the project scope. Host catalogs contain related host sources, or sets. Host sources or sets contain related hosts. And a host points at a single address, an IP or a host name, and can belong to multiple host sets. Targets link to one or more host sources to attributes that define a pattern of access to those hosts, such as a port number, a connection duration limit, a per-session connection limit, and any filters necessary to select specific workers to connect to that target. Unless the client specifies a single host to connect to, one is chosen randomly from the host sources or sets linked to the target. When a user asks to connect to a target, several things happen. The user's permission to open a session to that target is verified. A worker for the user's client to connect to, and a host for that worker to connect to are selected. A session record in the project scope is created, and the worker opens a connection to the target endpoint. A connection package is created and sent to the client, which then uses that connection package to securely connect to and mutually authenticate with the worker. The client opens a port on the user's machine that it then proxies to the worker for that connection. And finally, the user's application can connect through that local port. The worker receives the application traffic and proxies it to the target. For administrators of Boundary itself, the CLI is full-featured and even offers some friendly connection options of its own. You can actually both use the command line interface to set up targets to connect to the administrative points of the Boundary infrastructure, like SSH access to worker VMs, and then easily connect to those targets from the CLI as well. For end users, the Boundary desktop app provides a single presentation of authentication, available targets, and open sessions. There's also a web GUI that the controllers can expose for administrative use, and there is a full-featured Boundary API. Okay, time for the quiz. No, I'm just kidding. No quiz. I know that's been a lot so far. The big takeaway here is this. Boundary supports fine-grained control over every aspect of providing access to your environment, whether it's users connecting to things or administrators setting that access up. But I haven't even gotten to the best part yet. What I described previously is essentially the basic static view of Boundary resources. As stated, you would be managing all those resources yourself, and getting away from that administrative hassle was the whole point. But Boundary supports special dynamic collection and brokering resources that integrate with other systems and platforms, and dynamic versions of some of the basic resources as well. Let's take a look at those and how we can use them to add that self-management gene to our infrastructure. We're going to talk about 5 components of this self-managing access: managed groups, HashiCorp Vault's OIDC identity bridge, dynamic host discovery, on-demand credential brokering with Vault, and infrastructure as code. Managed groups are an abstraction of basic groups built on Boundary's OIDC integration. Where a regular group includes users directly in a static list, a managed group defines a filter clause. Managed group membership is evaluated when an account logs in. If the account matches the group's filter, it's part of the group. Managed groups can be treated as role principals just like static groups can. Instead of coming back to Boundary to manage group memberships every time somebody needs to be granted access, you can simply set up the necessary auth methods, managed groups, and roles in Boundary once, and then create new user accounts in your identity system like you always have, with appropriate attributes in the identity provider to make sure they match the Boundary managed group filters they need to match. But what if your existing identity provider is something besides OIDC? You don't have to replace or recreate your existing identity systems to use them with Boundary. Recent versions of HashiCorp Vault include a tech preview of an OIDC bridge. A Vault administrator configures the bridge with a template that defines how to translate user info from other Vault-supported auth methods, like LDAP, into OIDC claims. Boundary or another OIDC client can then use Vault as the OIDC provider. Boundary users will be redirected to Vault to log in just as they would with other OIDC providers like Okta or Google. Dynamic host discovery is a similar concept to managed groups. Boundary is looking outward to a part of your environment and evaluating memberships based on what it finds at that instant. In this case, instead of users in a directory, Boundary has dynamic host catalogs, each tied to an infrastructure provider. The catalogs contain various host sources defined in part by filters that determine their membership, and Boundary is examining your infrastructure for info about what resources tags or other attributes match those filters. Note that where the initial querying for the user data to filter for managed groups is built into Boundary because the APIs are well known, dynamic host catalogs use platform-specific plugins, just like Terraform does, and for a similar reason. Every provider will have its own API and its own schema for the data returned by it. Just like Terraform provider plugins, the dynamic host plugin's job is to act as a translation layer between Boundary's internal concept of hosts and the reality of whatever exists in the target environment. But instead of creating infrastructure, it's querying what already exists. Currently, there are HashiCorp-supported discovery plugins for AWS and Azure, with lots more planned. With these 3 pieces, we can authorize a user to make a TCP connection to a piece of infrastructure in a self-maintaining configuration. All the mechanical pieces are in place. But there's one more feature Boundary supports that gets users all the way past the last hurdle they face on many access paths. They'll need some kind of credential to authenticate to the target endpoint. That might be an SSH account username and password, a cloud provider IAM credential, or something else. Boundary can provide that credential on demand using a credential library that is part of a credential store. The first credential store integration that we've shipped is for Vault. Boundary can read a secret path and provide the secret to the client when a session is authorized. Since Vault supports on-demand generation of ephemeral credentials for a variety of different types of authentication, This means that in many cases, the credential provided at connection time can actually be dynamically generated with a limited TTL to mitigate the risk of long-lived static credentials. So now we have all the connection pieces, dynamic authorization at runtime based on users' attributes in a wide variety of identity providers, dynamic target configuration based on resource configuration in the infrastructure provider, and even dynamic credentials to log into the target. Done? Not quite. Although the load of maintaining Boundary itself is now minimal when all these features are in play, you still have to maintain your underlying infrastructure and identity platform. And that means that how you maintain those makes a difference to your administrative load, not just how you set up Boundary. Often these things are handled by operations or support staff working from detailed runbooks based on tickets in a queue. The runbook itself is rarely the issue. As a rule, any errors there are found and fixed pretty quickly. No, it's not the runbook. It's us humans who are running it. We make mistakes, we get distracted, we forget to do things, we just plain have bad days sometimes. It's just how we are. But this self-managing workflow breaks down if humans miss things like adding a new user to a group or adding a tag to a new instance. We need to move away from ticket-driven, runbook-oriented provisioning and put the robots in charge. I hear Cyberdyne Systems has some new models about to go into production. Okay, maybe not those robots. Automation is critical for ensuring consistency. And if you guessed this is where I'm going to finally talk about Terraform, you're absolutely right. The most obvious point here is that if you create infrastructure using Terraform, you can build in various levels of compliance. You can use variables to parameterize your resources so you can create them with the variations you need, without worrying about losing consistency in the parts that need to stay consistent. You can create modules representing complex patterns so that you can deploy them as a unit, while ensuring configuration and relationships between multiple resources are standardized. And if you have a Terraform Enterprise or Terraform Cloud paid subscription, you can define mandatory policies that will actually stop deployments that don't meet the requirements you set. But automation alone won't get you all the way there. If the automation for infrastructure is still completely separate from the process for infrastructure updates, now you have two abstractions that you have to dive into to resolve discrepancies when they get out of sync, and they inevitably will get out of sync. You need to build the update process for your identity systems into the one for your infrastructure, so that they are no longer separate, but part of one unified flow, despite the changes happening in different places. Fortunately, Terraform is for more than just compute infrastructure. There are Terraform providers for all kinds of resources you might need to manage. You can create new users in a variety of identity systems with providers for them, create vault secrets with the vault provider, and configure the dynamic resources you need in Boundary with the Boundary provider. Everything stays in sync. No more missed infrastructure tags, no more forgotten group assignments. Even the little bit of effort still involved in maintaining this is smaller than you hoped. Routine infrastructure and user identity changes become quick list updates and code merges instead of lengthy runbooks. And that update not only updates your infrastructure, but keeps your access profile in sync with it. Let's take a look at this in action. So, jumping right in here, I've got a few things that I've already done just to set this up ahead of time. You can see here I'm logged in as a built-in admin in the Boundary system that I've set up. If I look at my auth methods, I have this OIDC auth method that is also already something I set up. That's not a pre-formatted auth method. And it's got these managed groups here. And if I look at this managed group and I look at this memberships, I am a member of it. The other thing is if I look at my host catalog here, you can see I have different hosts in the host catalog, and those are based on just the tags. If I actually read the tags on that host set, the first thing I have to do is host sets list and then scope, or actually host catalog ID, because they are associated with a host catalog ID, and the host catalog ID is this here. And so if I look at my host catalog ID, now that is a host catalog based on a plugin, and you can see this host set is also based on a plugin. And so if I read that host set, we'll actually see what that is based on. Host sets read. Okay, read. And you can see here the filter that we are using to determine what VMs end up in the host catalog, the host set rather, is these filters here. And so I have tags in my Terraform code that update my tag my VMs so that this host set will be updated with them. So let's see here. If I do a hosts list, I wonder if I can do host set ID and then this. Let's see, host set ID. I guess I can't do that. Just check the help real quick. Host catalog ID, format, token name. Yeah, no, so you can't do it by host set ID. You just have to do it by host catalog, which we already did. Now you'll notice there, even though my Terraform currently has 1 provisioned in the environment, the host catalog still has 3. That's because the host catalog takes a little bit of time to update. It does update eventually. So right now I have 1 host and I have 3 in the catalog. Earlier I had 3 hosts but only 1 in the catalog because I had just created 3. So I'm going to jump out of full screen on this now, and I'm going to, I've already updated my Terraform code. I'm going to go ahead and kick off Terraform apply. And what that's going to do is it's going to, create 2 hosts, which then will take time to update. That's going to take a little while to do. One thing I did want to go back in here and point out is that the Boundary admin user interface, the Boundary admin web interface, does not show those host catalogs yet if they are plugin based. You can see here the only thing that I can see is my generated host catalog. That is the one that's created by the Boundary init process. So now let's see, we might, well actually we don't have users here yet, even though they're getting created in the background, because you don't actually become a member of a managed group until you log in. And then Boundary examines your login info, your attributes, and then it says, okay, you match with the filters in these managed groups. Now you're going to be a member of those managed groups. And that evaluation happens every time you log in. So let's jump back out of full screen here and take a look. Oh, it's done the plan. Now it wants to do the apply. And then if we full screen this back again, we will eventually see, if I do a watch on this, you might actually get to see. So you can see we're down to 1 host. It finally caught up with reality, but now I am changing reality again, so it'll take it a little time to catch up. In the meantime, I wanted to point out a couple of other things here. We have the managed group, we have the members. The member of the managed group is an OIDC account, okay? And then that member, that OIDC account, is also associated with a user. And so if we go down here and we see this account is, you can see I have my OIDC account there. I think this might be somebody else. Resource not found. That's a user that needs cleaning up, I think, from an earlier run of this. So let's take a look at how things are going with Terraform. The Linux virtual machine is getting created. The Boundary admin. Let's see how long this is going to be. It's usually pretty quick to create the VMs. I'm hoping that it's creating or has already maybe created my managed group. I'm hoping it's already created my new user there, but I'll show you what that looks like actually. If I go into main.tf, you can see I have edited my Boundary admins list. This is a variable that I'm passing into the module, and I added Bill the cat Bill the Cat's going to be an admin user. Kind of a scary prospect if you know Bill the Cat from the comic strips. The other one is my Azure, not Azure VM, Boundary infra main.tf. You can see I have my Azure VM count there that is now 3, and that's why Terraform is creating my extra 2 VMs, because I had previously updated that but hadn't actually done that apply yet. So my apply is running. Let's see if I need to get the password for this account when it finally gets created, and that password is going to be this. I use the same password for all of them, as you can see. So let's go over here, and I will de-authenticate with whoever I am there. And now I'm going to authenticate, and you can see I've done this several times. I'm going to use another account, Bill the Cat at, what is it? Oh, Azure. Little thinko there. HashiCorp test. This is our .com. Okay. Next. And it says, what is your password? Now, hopefully, we'll see if I actually got through here. Yep. Okay. So, Bill the Cat is now a user that has been created. It says more, and well, he's getting created, I think. So we can see this fully automated flow happening for real. We created new VMs in our infrastructure, and we created new users in our identity system, and those two things were automatically picked up by Boundary, so we can give those new users their appropriate level of access to that new infrastructure, without any need to touch Boundary itself for this routine change. This is easy to implement now that Boundary has support for the foundational pieces it's built on. But it represents an enormous shift from the way access was traditionally handled. We're no longer required to perform this runbook-based, error-prone, detail-oriented process that depends on a human's time and attention. We make the minimal set of required changes, they're applied in a unified, automated flow, and access changes track infrastructure changes all by themselves. That's the kind of power I wish I'd had from the beginning of my system administration career. I'm thrilled that we're bringing that kind of power to people maintaining these things today. I want to close with some final thoughts and pointers to more info, but unlike a lot of talks, these are not just static links to go read and absorb. This is a call to adventure. Boundary is constantly evolving, and the more community engagement we have, the faster we can improve it, and the better we can make it. First, I want to point everybody to the other Boundary talk that was earlier in the 24-hour schedule. Zero Trust Security and Identity Management with Boundary at 10:35 GMT. Obviously that's already gone by, but I recommend watching that recording, as I think, by judging by the title, that that'll be a good overview of Boundary generally. Also, please go check out the Boundary documentation here, and if you see something that's unclear, doesn't match how the current version of Boundary behaves, or something seems not to be there that should be, use that Edit This Page button. That's going to take you to the Boundary Docs GitHub repo, and you can raise an issue or even become a contributor and submit a pull request directly. We also have a collection of Boundary tutorials on our Learn site. This is linked from the docs page as well, but here's a direct link. Boundary is constantly evolving, and the more community engagement we have, the faster we can improve it and the better we can make it. First, I want to point everybody to the other Boundary talk earlier in the 24-hour schedule, Zero Trust Security and Identity Management with Boundary at 10:35 GMT. Obviously that's already gone by, but I recommend watching the recording, as I think, judging by the title, that that'll be a good overview of Boundary generally. Also, please go check out the Boundary documentation here, and if you see something that's unclear, doesn't match how the current version of Boundary behaves, or something seems not to be there that should be, use that Edit This Page button. That's going to take you to the Boundary Docs GitHub repo, and you can raise an issue, or even become a contributor and submit a pull request directly. We also have a collection of Boundary tutorials on our Learn site. This is linked from the docs page as well, but there's a direct link embedded here. There's lots of great material there, and I highly recommend running through as many of those as are relevant to you as you get started with Boundary. And check back often after you're done, because our team is updating the Learn site all the time. If you're looking for some getting started code to experiment with yourself, we have the Boundary Reference Architectures repo here. Some of them are due for updates that we're working on, but in the meantime, if you download or clone the repo and just update the Boundary version in the code you're working with, things should pretty much work without further changes. And if they don't, issues and pull requests are always gratefully accepted. While you're figuring out how you want to use Boundary, we have the Boundary area of our Discuss site. It's pretty active, and members of the Boundary team keep a pretty regular eye on it. Last but not least, the core thing itself, the Boundary repo. Just like the Reference Architecture repo, there's plenty of things the team would love help with, and there are always opportunities to easily help extend Boundary by writing new plugins for things. I'll close this talk out with a little bit of open source philosophy. Boundary is a new project. It's still being built, and there are a lot of areas of its code base that are still very much yet to be determined. Not to put too fine a point on it. Right now is a great time to dive in and help the Boundary team determine those things. That doesn't just mean writing code, by the way. We love code contributions, but we also need eyes on documentation, people raising GitHub issues when they have trouble, and people helping other people in our forums. You can help a ton without ever writing a line of code. Thank you, and if I haven't already, I hope I'll see you around the Boundary community soon.